right, ladies and gentlemen, we are looking at these guided notes for quadratics. We had exploring yesterday with the calculator. So now we're going to go through some of the rules and what we need to know about this. So the first thing we're going to start with is transformations are all about how things move. Let's look at the basic quadratic function of x squared. And there's a picture of it right there. Basic thing of x squared. We refer to this as the parent function. Whenever we talk about transformations, we talk about how it moves from the parent function. Okay? And we're going to analyze transformations on this basic equation in vertex form, which is y equals a times x minus h squared plus k.
So what's h and k?
Okay, so h is our horizontal translation. It moves to the left. If it's added to x, it moves to the right if it's subtracted. K moves my graph up or down. Okay, up if it's positive, down if it's negative. A is my reflection and dilation. It talks about if I open up or down, and it stretches me. If it's A is greater than 1, it stretches vertically. So it looks like somebody's grabbing my hands and pulling me up to the air, so I get smaller and smaller between. And if I'm compressing, if it's between 0 and 1, it looks like somebody pushed down on my hand, so I'm getting wider and wider. Okay. So we're going to graph this on here and talk about what transformations took place. Okay, so first of all, let's talk about what the vertex is for this. We've got y equals x minus 5 squared plus 3. This is y equals x squared on here, and now I'm going to make my graph for this one. So what is my vertex? We talked about this a little bit. No, so my vertex for this is 0, 0. For my new one that I have not graphed yet. So remember, h and k are my vertex. So it's going to be positive 5, 3. It's the opposite of this. Remember, it tells me right here, it moves left if h is added to x. Okay? The axis of symmetry is x equals 5. Okay, so my transformations, I'm going to go 5 units to the right, 3 units up. So I'm going to move. I'm going to show my new graph. I'm going to go over 1, 2, 3, 4, 5, up 1, 2, 3. And that's my new graph. That's my transformation that happened there. It doesn't ask for this one, but this would be a what? Minimum. Good. Okay. Next. Yep, I'm not going to move it. All right. I want to figure out my vertex for the next one.
We can't do this in the calculator.
Well, I want you to be able to do it both. Okay? So what's the opposite of negative 4? It would be positive 4, right?
Is it 4, 0?
4 is 0 because nothing's being added to it. My axis of symmetry, where I could fold it in half and it would be the same on either side, is x equals 4. It's always the x value. Okay.
So it just be on the x.
So wait.
Okay.
We're going to talk about where it moved. I moved
Left 4.
right 4. Okay? But look at the negative 2. So that means I reflected over the x-axis and stretched by 2. So it's going to get narrower. It's stretched.
So
Okay, so I'm looking at right here, I'm going to go over 1, 2, 3, 4. That's my vertex right there on the x-axis. But remember, it's going to be pointing up or down? Down. And it's going to be narrower.
What is the negative two?
-2 flips it so it goes down, and then the 2 makes it go narrower. So if this is my regular,
Okay, so it goes
Down.
in back to-
I don't like
you don't have to like it, we just have to do it. Okay,
So then when I was
stretched by 2.
and then reflected by.
Reflected over the x-axis and stretched by 2. Okay. We are going to go ahead and look at the next one. What is my vertex for this?
Negative 6, negative 3.
Yeah. My axis of symmetry is x equals
Because it's opposite.
opposite of this. It says it right up here. It's the opposite. Okay, so x equals -6. So let's talk about the transformations. I moved which way, right or left?
You moved left.
Left 6, and I moved up or down?
Down.
How much?
3.
Good.
I'm cold.
Okay. Did I flip over the x-axis? Is it negative in front?
No.
But I stretched by 1/2 or compressed, we can call it, either way.
Did you start? Yeah.
How you know if you press it in?
Right here in front, the A. The A tells me if I stretch,
Oh, if it ain't nothing in the front.
yeah.
I want to see.
So I'm going to go -6, 1, 2, 3, 4, 5, 6, down 3, 1, 2, 3. Okay? And I'm stretched, so I should be wider.
Huh?
It should be wider.
Why?
Because 1/2, it says right here, if it's between 0 and 1, it is wider.
What if we don't?
Oh, it's not reflected. I did it wrong.
Oh my God.
It's not reflected. I'm going to keep going.
Oh, I see what you're saying.
That's good. How do you know if you press it?
Negative, if it's negative. So number 2, see that a negative in front? That means it's reflected. This one was not.
So we just
It's
use
positive.
it as a minimum
Yes,
and it's pretty wide.
yes.
Right here.
Okay, let's go ahead and turn it over.
It's kind of easy, but I feel like you're going to add something.
Okay. We haven't talked a lot about standard form. We're going to be doing that next week. Okay? We're worrying right now about vertex form, so we're not going to do examples right here because we're going to do that next week. Okay? We're going to look right here, way down at the bottom, and we're going to rewrite this equation with these instructions. Write an equation in vertex form, given the graph has a vertex of -4, 3, and we're not going to do this because we don't need to go through the point. I think we're going to move to a homework.
Sounds like a good idea.
Good stuff.
I think that's what we're going to do. Okay, so I'm going to do one problem on the front and one problem on the back so you guys feel confident doing this. Okay?
Hold on, can you wait till I come back? Or
Just let me do this first before you go.
I ain't want to go back.
Okay. All right, so I am still working on this. Oh, you guys don't have the homework.
Nope.
Oh, look, you're up. Why don't you pass the homework out to everybody? I'll put one at your seat and Kevin's seat. Here we go. Okay. So, shh, pass out the homework. Give each table as many people as there. Shh, 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 shh. Okay. So, we're looking at this right here. We're looking at number 1. And we're going to tell the transformation. Excuse me, I am teaching currently and recording this. Here, steal no.
No, wait, that's your mouse.
Okay. All right. So we're going to talk about the transformations that take place. That means you should be using words like right, left, up, down, reflected over the x-axis, stretched. Okay? So, if we're looking right here, at this first one, which number, 4 or 5, tells me give yourself one, if I moved right or left?
4.
4. And 4 is going to tell me what? That I moved?
4.
Left.
Wait, how?
It's the opposite. That was the whole notes that we did. Okay. Did I move?
Yes.
And then you
No.
right 5.
No. Jamel.
No, you moved up 5.
No.
I moved up 5. Okay.
You should have moved right 5.
So this is important that when it's inside the parentheses, it's the opposite. But when it's outside, it's the same. Okay? So my vertex is?
It is negative 4, 5.
Okay? And my axis of symmetry is x equals?
Wait.
No. X equals, what's the axis of symmetry?
Oh, x equals 4.
Negative 4. Okay? It says equation of axis of symmetry, so they should always say x equals. Does that make sense?
Yeah.
Okay, let's turn it over on the back. Okay,
What did x equal?
x equals negative 4. Okay, we're gonna match these graphs with this. I'm not gonna do B, I'm not gonna do A, I'm gonna do B, because you have to put it in vertex form first. So we've got, for B, we've got y plus 2 equals x plus 2 squared. I need y by itself, right? So I'm just gonna subtract 2 from each side. And now B is y equals x plus 2 squared minus 2. Now I'm going to think about my graph needs to look like my vertex is negative 2, negative 2. So I've got to look on here. Now these are poorly drawn, right? But like if you draw over where the x and y is, it's better. Okay? All right, so we need a positive 1. So I know these 3 don't work, so I've narrowed it down to these 3. Right? My A is positive. My A is positive. It's going up. B.
Oh.
So I'm canceling these 3 out. So I'm just looking at these 3. 1, 2, 3.
Do we x them out or just
No, just because you're going to need them to match with the rest of them. Okay? So which one of these is negative 2, negative 2? So here's the y-axis, here's the x-axis. That's not negative 2 away, right? That's more than that.
Is it 3?
It's 3.
So what
So
would
B goes with 3. They go together. Or you can write next to 3B. Okay? So that's what you're going to do for the homework. You've got the rest of the hour to work on it. Hit stop.